Today I'll go through 2017 AP Physics 1 free response question. I'll try go over it in detail, okay? Number 2. Student wants to determine coefficient of static friction between wood board and wood block. So you're trying to find mu s, right? Describe experiment for determining coefficient of static friction. Equipment, blah blah blah. Draw diagram, set up the board and block. Describe overall procedure. And reduce experimental uncertainty. So probably you'll have to say repeating, taking multiple measures and take an average out of it. And drive equation. Okay. So these are actually typical questions from the textbook. So let's look at a ramp first. So when you have a ramp, what are the forces acting on this? So you have gravity going down. You can draw from center of mass or start from this point, doesn't really matter for this question. So that's mg, and there will be normal force going up. And if there's a friction, will go there, right? And in this case, or friction is mu Fn. Now, depending on mu s or mu k, you'll have to use different mu, right? And you actually have to break this down when you actually do xy component. So since this object is moving in that direction, you want to choose this as x-axis and that as y-axis, right? Now usually you have to say f net y is 0 because this block is not moving up or down, and f net x, which is in this direction, will eventually become ma, right? Now let's go over this quickly. When you break this mg component, I know a lot of times, or in a textbook, it shows like this. So breaking this vector as mg, sum of these two. But in fact, if you use the other triangle, such as, let's say this is mg, you break this component, one along the slope and one perpendicular to this, okay? This picture is actually a lot easier to read because then you can say this angle equals that angle because this is parallel line, so you can reason this parallel line, that will be corresponding angle, and this angle is 90 and that angle is 90. So since two angles of triangle is equal to two angles of large triangle, you can say third angle, which is this angle, has to be equal to each other. Then you can reason it. This component will be the opposite of this angle theta. So this angle, this side will be opposite of this angle theta. So I know slope, the force along the slope will be mg sine part, right? And the force pulling into the ramp is the adjacent of this triangle, so that will be mg cosine theta. So next time when you break the component into the ramp, so try, if this is mg, break it into 1 and 2, and that will be sine portion, this is cosine portion. Since this ramp question comes a lot, probably later on, once you reason this, probably you just want to memorize. Sine will be along the slope, cosine is into the ramp, okay? Now, and then basically you have this force, which is mg sine theta, right? and you have normal force. In this case, this normal force will cancel gravity portion, which we agreed on cosine theta, right? So this portion will be mg cosine theta. So normal force has to cancel that, otherwise the block will move up or down. I mean, moving in this y direction, which is not true. This is only moving along the slope. So this normal force has to be mg cosine theta, right? And then you have force of friction. Now, force of friction will be mu mg cosine theta, because force of friction is mu Fn, right? But there are actually, I'll give you another lecture on how to deal with static friction and kinetic friction later. This gets a little tricky in case of static friction, actually, because in a static friction case, there's actually less than equal sign. I'll have to spend like another 20 minutes to explain why there's less sign. So I'll just go through this question quickly. All right, so what's F net? So F net will be mg sine theta for extraction minus force of friction, which is mu mg cosine theta, and that is equal to ma, right? But here you're looking for mu s. So basically, when you have a board and a block, and if you raise this board, at some point, at a certain angle, this will start to slide, okay? So that's what you're trying to measure. So basically, so let's call this angle minimum. So until you reach angle minimum, the block is not moving. That means acceleration will be 0. As soon as you reach theta minimum, it starts to accelerate. So until you reach that angle, acceleration will be 0. So to find theta minimum, you set acceleration equal to 0, okay? So in that case, you have mg sine theta equals mu mg cosine theta, and you can cancel mg. So basically, this mu is not depending on mass, right? So this mu will be sine theta, if you divide by cosine, over cos theta. So that's basically tangent theta, right? So let's say you did the experiment, and when this makes, let's say, 30 degree, it start to slide, then I know mu as between the block, this small mass, and the board. So you actually have to always give two surface. So would in this case, would block to would, what do they call this? Would board equals tangent 30 in this example, okay? If this was 30 degree, that start to slide, okay? So I already know the answer to part B, because so mu s is tangent and theta, and you have to write this as the derivation, right? Now draw the diagram experimental setup, which I already explained. So something like this, right? So you have the board, you have the block, you raise this angle, and you measure the minimum angle when it start to slide down, and you'll repeat this several times and take average of this angle, and so average of this angle, and take that as mu s between two surfaces. Okay. All right, so let's move on. Our physics class consists of 6 lab groups. So they are testing the hypothesis that coefficient of static friction between board and block. Each group determines coefficient of kinetic and static friction, and the group result shows below, and class average indicated the bottom row. So if you look at the average, the coefficient of kinetic friction, coefficient of friction, there are 6 groups. Average of mu k and average of mu s was equal. This is a little bit odd because mu s is usually larger than mu k, okay? Based on the data, what conclusion could the student make about hypothesis that coefficient of static and kinetic friction is equal, static kinetic friction is not equal? So you should say they are not equal, although their average is equal, because if you look at the data, all of a sudden it's like 0.45 range. This guy shoots up and this guy goes down. So basically this will raise average, this will lower the average of the groups. So basically group 5 is outlier. So you should say group 5 is an outlier. Right, so they made an error probably. Because of that, mu s. So if you take this away, this looks like 0.445 around that range, and this one is like 0.554 range. So mu s is actually bigger. So if your group 5 is an outlier, so if you take them away, mu s will be bigger. Now a metal disc is glued to the top of the wood block. The mass of block disc system is twice the mass. So does the mass make a difference of the mu s, right? So, but it's not gonna change because once again, this mu s came from, okay, I'm gonna rewrite one more time, mg sine theta, and force of friction, and normal force was normal force was mg cos theta, right? So normal force is mg cos theta, and force of friction is mu mg cos theta because it's mu fn. So f net equals this minus that. So that's mg sine theta minus mu mg cos theta equals ma. And remember, you set this equal to 0 to find mu s, and that's your minimum angle, and this mass will cancel out. So mu eventually become tangent theta, right? So due to that, you can explain like that. Mass will cancel from the equation. So mu is not depending on mass, right? All right, that was part D. Right?